Yeah, good morning, sir. My name is Nagaraju, and I am here to present the PPT. My topic is Wi-Fi Beacon, expanding BLE location-based services via Wi-Fi. So, coming to the introduction, the main problem in this is high hardware cost and the maintenance complexity of Bluetooth low energy location-based services. Existing solutions require additional hardware and significant modifications to mobile devices, which renders the service incompatible with billions of unmodified devices. Additionally, BLE LBS requires periodic frequency hopping to increase the detection probability, which can cause interference with Wi-Fi and the degrade Wi-Fi network performance. The importance of solving this problem lies in potential benefits of BLE LBS, such as improving the efficiency and accuracy of logistics and the transportation services, enhancing the customer experience in retail and hospitality, and enabling new applications in healthcare and smart cities. However, the hardware cost and maintenance complexity of existing solutions limit the widespread adoption of BLE LBS. The key idea proposed in the paper is why WIBEACON, a low-cost solution for large-scale BLE location-based services that repurposes existing Wi-Fi infrastructure without requiring additional hardware. WIBEACON addresses technical challenges to ensure compatibility with unmodified mobile devices and seamless integration with Wi-Fi services. The two-way pilot study confirms that WIBEACON's reliability and accurate location-based services, making it a practical and efficient alternative to conventional BLE beacons. Coming to the related work of this topic, using Wi-Fi signals for BLE LBS, some works have attempted to use Wi-Fi signals as a supplementary data source to enhance BLE location-based services. They explore the possibility of utilizing Wi-Fi infrastructure to provide additional location information along BLE beacons. Machine learning based Wi-Fi signal calibration. Another set of related work focuses on using machine learning algorithms for Wi-Fi signal calibration. These methods aim to automatically calibrate Wi-Fi signal strengths and improve the location estimation accuracy in indoor technologies. One of the limitations of existing works in cross-technology communication is that they cannot produce iBeacon broadcasts without chip error due to imperfections of the emulator signal. This makes them incompatible with unmodified mobile devices, which inhibits large-scale deployment of BLE beacons. Next, coming to the overview of this topic, the key idea of vBeacon is to leverage existing Wi-Fi access points to serve as virtual beacons, enabling large-scale BLE location-based services without the need for additional hardware. vBeacon achieves this by repurposing standard Wi-Fi frames with elaborately selected payloads to emulate the frequency hopping function of iBeacon, making it compatible with unmodified mobile devices and seamless integration with Wi-Fi services. The system administrator remotely upgrades and configures the vBeacon software on deployed Wi-Fi APs. The APs then periodically broadcast the modified Wi-Fi frames, which can be recognized by mobile devices in same way as describing the standard iBeacon location broadcast. Next, the vBeacon is carefully integrated with Wi-Fi services to maintain high-speed services for Wi-Fi clients. This practically vBeacon is further validated through a real communication LPS in meal courier tracking, demonstrating comparable reliability to conventional BLE beacons with extensive experiments involving 150 types of smartphones. Next, detailed idea of proposed solution. vBeacon repurposes existing Wi-Fi access points into virtual BLE beacons, providing a low-cost solution for large-scale BLE location-based services without requiring additional hardware or Wi-Fi client cooperation. The solution consists of vBeacon scheduler and injector, which work together to schedule and inject BLE beacons into Wi-Fi frames using code-based sequence. vBeacon addresses technical challenges to ensure compatibility with unmodified devices and seamless integration with Wi-Fi services while maintaining high-speed Wi-Fi services for clients. And next will be continued by my friend Sai Kumar.
Hello, this is Sai Kumar. I am going to set up WebBeacon scheduler and injector. The WebBeacon scheduler is responsible for scheduling the BLE beacon injection. It uses for a codebook determine the BLE beacon sequences, which is then used by the WebBeacon injector to inject the BLE beacons into the Wi-Fi frames. The codebook is a predefined set of BLE beacon sequence that are used to emulate the frequency of hopping function of a beacon. The WIBEACON scheduler also take into the account the Wi-Fi traffic load and adjust the BLE beacon injection, the rate according to minimize the interface with the Wi-Fi traffic. The WIBEACON injector is a response for injecting the BLE beacons into the Wi-Fi frames. Actually, it uses the BLE beacon sequence generated by the WIBEACON scheduler to inject the BLE beacons into the Wi-Fi frames. So that the WIBEACON injector also take into the account the Wi-Fi frames format and adjust the BLE beacon injection rate according to the minimize the interface with the Wi-Fi traffic. The WIBEACON injector is a carefully integrated with native Wi-Fi services, retaining the transparency to the Wi-Fi clients. Moving to the next slide. Moving to the next slide. The summary of proposed solution of WIBEACON. Uh, The WIBEACON utilizes a predefined codebook to generate a BLE beacon sequences. Emulate the frequency hoping the function of a beacon is a while minimizing the interface with the Wi-Fi traffic and ensuring the capability with unmodified mobile devices. The careful integration with the nationwide Wi-Fi service enable the WIBEACON to maintain the high-speed Wi-Fi services for client while broadcast the BLE beacons transparently, ensuring a no degradation in performance. WIBEACON is security is reunified by the strong Wi-Fi authentication mechanism, providing the better protection compared to the Bluetooth beacons, and it does not violate the public privacy as it only broadcast identifies without collecting the Bluetooth packets. As a cost-effective solution, WIBEACON is a repurpose existing Wi-Fi infrastructure requiring no additional hardware and minimal remote configuration for large-scale BLE location-based services. By addressing the technical challenge in the cross technology designs, WIBEACON achieve the seamless compatibility with both Wi-Fi and BLE technologies, making it practically an efficient solution for location-based services. The main results of the paper is as we can see there are two figures in this slide. They are A and B. The for A is frame reception ratio and B is received signal strength. Coming to the figure shows that RSSI distribution of WIBEACON and BLE beacons in a lab environment. So that the results show that WIBEACON has a similar RSI distribution to BLE beacons, indicating that WIBEACON can provide accurate base services. Yeah, you can look at the two graphs. Red color indicates a BLE beacon and blue one indicates a wave beacon. It shows that the percentages also is a distance. Moving to the next slide, the it shows that the figures show the snapshot of IBCon scanners in Nexus 5 with unique locations, identifiers, and the estimated proximity of WIBEACON. This provides a visual representation of the proposal solution in action. We can move to the snapshot of the peak of pie chart. There the Samsung is at 2%, Xiaomi is 19%, the Oppo is at 28%, and Vivo is at 36%. Then the mostly the highest was Huawei, the 47%. The second place in the Vivo, the 36%. Then moving to the next slide, the summary of the results. And we have two figures in this slide, like figure C and figure D. The figure C, we show that RSSI and comparison between the WIBEACON and BLE beacons in the real world pilot study. As a result, show that WIBEACON has similar RSSI and that WIBEACON can provide accurate location based on services in the real world environment. Coming to the figure D, we show that courier detection accuracy of WIBEACON and BLE beacons in a real world pilot study. The results show that WIBEACON has similar courier detection accuracy to the BLE beacons, indicating that WIBEACON can provide a accurate location based on services in real world entity. The finally we concluded with this. In conclusion, the WIBEACON present a cost-effective and efficient solution for large-scale BLE location-based services. By leveraging existing Wi-Fi infrastructure without a need of additional hardware, we can implement the Wi-Fi beacon without additional hardware, without any implement. Can run with virtual. The successfully 2-week pilot study showcase that WIBEACON is a reliability and comparable to the conventional BLE beacons. Actually, it provides a location service for meal couriers and tracking of food services. Actually, it provides the services like track, tracking of food orders. We have many social media platforms we can use this for this. With the robust security measures and privacy concerns, WIBEACON offers a seamless compatibility with unmodified mobile devices Wi-Fi services. This have a special of special securities. It provides a special security measures for the some mobile devices for Wi-Fi services. By addressing the technical challenge, WIBEACON proves to get practical and accessible of option for integrating the BLE location service into existing Wi-Fi setups. The potentially revolution the deployment and utilize the BL beacons. The the future work for Wi-Fi beacon. What is the future for this? The future work of Webicon is included designing a more efficient scheduler with data driven of Wi-Fi traffic predictions and cooperation with Wi-Fi vendors to the customize the firmware and reduce the channel switching overhead. Additionally, explaining a Webicon impact on battery life and its potential in indoor navigations and large scale deployments, as well as investing in compatibility with other wireless technologies like Zigbee and LoRa. These two technologies we got compatibility with this. And thank you.